Welcome to the class of Advanced Statistics and Econometrics. In today's lecture, we are going to discuss multiple discriminant analysis. And the learning objectives of this chapter are state the circumstances under which a linear discriminant analysis should be used instead of multiple regression. Identify the major issues relating to types of variables used and sample size required in the application of discriminant analysis. Understand the assumptions underlying discriminant analysis in assessing its appropriateness for a particular problem. Further learning objectives are describe the two computation approach for discriminant analysis and the method for assessing overall model fit. Explain what a classification matrix is and how to develop one, and describe the ways to evaluate the predictive accuracy of the discriminant function. Tell how to identify independent variables with discriminatory power. Justify the use of a split sample approach for validation. Discriminant analysis defined. So multiple discriminant analysis is an appropriate technique when the dependent variable is categorical, nominal or non-metric, and independent variables are metric. The single dependent variable can have 2, 3 or more categories. Examples are gender, male and versus female, heavy users versus light users, purchaser versus non-purchaser, good credit risk versus poor credit risk, members versus non-members, attorney, physician or professor. So these are, you can see, categories, and we are going to assign category to our observation based on our analysis. So this example, kitchen aid survey results for the evaluation of a new consumer product. So there is a new consumer product, and it is going to basically get evaluated on the basis of 3 parameters. So independent variable are 3: x1, x2, x3. x1 is durability, x2 is performance, x3 is style, and there are two groups, group 1, group 2. So you will see in group 1 we include those who would purchase, and group 2 we include those who would not purchase. So suppose we have 1, 2, 3, 4, 5 are going to purchase, and 6, 7, 8, 9, 10 are not going to purchase. So you look at this, their ratings, basically durability on the basis of 1 to 10, 8, 6, 10, 9, 4 are the observation for durability. For those who are likely to purchase, and mean is 7.4. Whereas those who are not likely to purchase, their mean is 3.2. Observations are 5, 3, 4, 2, 2. This is for first variable durability. You have second variable performance, and for this variable, those who are likely to purchase, their ratings are 9, 7, 6, 4, 8. So average is 6.8. Whereas those who are not likely to purchase, their average is group mean is 4.4. So 4, 7, 5, 4, 2. So you see x1 and x2, the group mean difference is 7.4, 3.2, and x2 6.8 and 4.4. So the difference is 4.2 and 2.4, and x3 is 4 and 3.8 are the group means. So the difference is much less. It is 0.2. Evaluation made on 0 to 10. 10 is excellent and 0 is very poor rating scale. So on the basis of these three variables, x1, x2, x3, we are going to say that 1, 2, 3, 4, 5 are likely to purchase, and 6, 7, 8, 9, 10 are not likely to purchase this product. So graphic illustration of two group discriminant analysis. So we need to come up with a discriminant function. So you have A and B, and then this is going to maximize the group mean differences. So we need to put weightage of all these, and weight should be chosen such that it is going to maximize the group mean differences. Discriminant analysis decision process. Stage 1 is objectives of discriminant analysis. Stage 2 is research design for discriminant analysis. Stage 3 assumptions of discriminant analysis. Stage 4 estimation of discriminant models and assessing overall fit. Stage 5 interpretation of the results. Stage 6 validation of the results. So in stage 1, objective of the discriminant analysis, determine if statistically significant differences exist between the two or more a priori defined group. So we have already defined the group a priori, and we need to determine if the statistically significant difference exists between these groups. Identify the relative importance of each of the independent variables in predicting group membership. Establish the numbers and the composition of the dimensions of discrimination between groups formed from the set of independent variables. That is, when there are more than two groups, you should examine and name each significant discriminant function. The number of significant function determines the dimension discriminant function and what they represent in distinguishing the groups. Fourth one is develop procedures for classifying objects, individual, firms, product, etc. into groups, and then examine the predictive accuracy, hit ratio of the discriminant function to see if it is acceptable, that is greater than 25% increase. Research design for discriminant analysis is stage 2. So we need to do selection of dependent and independent variables, sample size total and per variable, sample division for validation, converting metric variables to non-metric. Most common approach to use the metric scale response to develop non-metric categories. For example, use a question asking the typical number of soft drink consumed per day and develop a 3-category variable of 0 drinks for non-user, 1 to 5 for light user, and 5 or more for heavy user. Polar extremes approach compares only the extreme 2 groups and excludes the middle groups. So discriminant analysis design. Dependent variable must be non-metric. That means they must be categorical, representing groups of objects that are expected to differ on the independent variables. Choose a dependent variable that best represents group differences of interest. Define groups that are substantially different and minimizes the number of categories while still meeting the research objectives. In converting metric variables to a non-metric scales for use as the dependent variable, consider using extreme groups to maximize the group differences. Independent variable must identify differences between at least 2 groups to be of any use in discriminant analysis. Sample size must be large enough to have at least one or more observations per group than the number of independent variables, but striving for at least 20 cases per group. Have 20 cases per independent variable with a minimum recommended level of 5 observations per variable. Have at least one more observation per group than the number of independent variables, but striving for at least 20 cases per group. Have a large enough sample to divide it into an estimation and hold out sample, each meeting the above requirement. Assess the equality of covariance matrices with the box M test, but apply a conservative significance level of 0.1. Examine the independent variable for univariate normality. Multicollinearity among independent variables can markedly reduce the estimated impact of independent variables in the derived discriminant function, particularly if a stepwise estimation process is used. And the reference for all this is a book titled Multivariate Data Analysis, 8th edition, Publisher is Cengage Learning, and the authors are Hare, Babin, Anderson, and Black. And that's it for today's lecture. Bye for now.